All right. Well, we'll go ahead and without further ado, we'll leave the poll up for a couple minutes while everybody's getting logged in here. But thank you for joining us. Happy Earth Day. We're going to talk about unlocking myths around indoor air quality. Uh, Fortunate to be joined here by Rob Rotterman, who's a principal with Ramble. We're going to have a conversation today just about indoor air quality. So again, ask any questions in the Q&A section of the presentation. Uh, we'll try to address those as we go along, and we'll also take some of the questions here from the poll that's up right now and try to address those. Our agenda is pretty simple. If you've been kind of following our social media platform this week, we've been throwing out some things on LinkedIn, primarily about some things that we hear, things that people ask us about that are pretty common, and we'll talk about ozone, what's the great odor eliminator. We'll talk about volatile organic compounds. We're going to hit on mold. I'm excited to hear about mold here. It's always something that sounds scary, but may not be. And then we talk about secondary air cleaning. So these are things that are in addition to what we would use in common HVAC systems and in buildings to clean the air besides filtration. So that's our agenda. And then we'll kind of close it out with what you can do about indoor air quality going forward. So I'll kick this off, Rob, with ozone. You know, I think when we put our post up earlier this week, it was kind of on that theme of you know, ozone's one of those things. I think the quote is, "It's good up high and it's bad nearby." You know, the ozone layer is a good thing up in our atmosphere. It's a very thin thing. Global warming is causing it to deplete, which threatens the additional global warming. And when we get down low, ozone can be not necessarily good. I think it's been associated with smell and odors. You can smell it. I think, you know, Rob, I'm curious in your experience where you've come across ozone and some of the common maybe misconceptions about it and use in buildings.
Yeah, sure. No, just for background, you know, I'm an industrial hygienist with a background in epidemiology. So I'm not on the engineering side at all. I don't design or build anything. But I do go in and do air quality testing, do investigations, hopefully in advance of people complaining, but sometimes after you've had people getting sick in a building. Early in my career, 20 plus years ago, doing these ozone generators were being used quite a bit to remove odors, with claims about removing VOCs and killing mold and doing all kinds of stuff. And we would get called in where people were complaining about upper respiratory and eye irritation. And then we would simply walk in, see the ozone generator, unplug it, say, there, that should solve your problems, and send them a bill. They were used all over the place. And ozone is a very strong upper respiratory and eye irritant to humans. So yes, ozone will eliminate odors, but also yes, ozone will cause problems within your building. And when it eliminates odors, that doesn't mean they're being eliminated. It just means you're changing the molecule that's creating the odors to some other type of chemical. I guess the reason this is on the myth is just a reminder is, you know, Brad Caddick and I have been doing a number of these. We still see them being used frequently. Where we go into building, I think more sophisticated buildings have potentially gotten away from them, but we see them used under different names or marketed under different names. So when you read the back of your packaging for your air cleaning device that might say may generate ozone, don't use in occupied buildings, we see those being deployed. So I guess from a myth standpoint is we want to be careful about any technology that's going to generate ozone in an occupied building. And that's the bottom line for this point.
Yeah, and, you know, there are some things in buildings that can generate ozone as well. You know, you can put ultraviolet, some ultraviolet light can produce that with ionization. And so we've had some buildings have questions come to us where they have tenants coming back and they've read that ozone is very good with COVID and killing viruses or deactivating viral particles and, you know, killing things that are harmful to you. And looking about, let's put an ozone generator in our space overnight and run it for a while, and we'll shut it off and everything will be good. And that's one of those places where it's definitely not a good use. But, you know, as we talked, everything's got its own application. So buildings, I don't think is a place where we want to generate ozone. You know, we're looking at indoor air quality monitoring, and we don't need to put ozone in every building, but we've been putting in a lot of the office buildings because we're concerned that people might be bringing in things that do generate ozone. They might be installing bipolar ionization or other technologies that can emit ozone into the space. And so we're doing it kind of as a preventative measure to see if there's something being generated. But
Yeah, no, and I really like the title of your slide here, Ben, the correct application. I think that's gonna be a theme for the rest of this presentation is we have a lot of different technologies for clean air. It's just how are you using them and are you using them correctly for the right application? Ozone has its place. We see it in structural fires where obviously in a photo like this, you're getting rid of the drywall, you're getting rid of the cabinets, right? But in some buildings, you may want to save the framing, the wood, and you can clean the wood, but the wood is still semi-porous. It's going to retain some odors. So in a completely unoccupied building, very, very well ventilated, ozone might be able to be used to salvage some building materials, structural building materials that otherwise would be off-gassing odors. But in this situation, it's obviously going to be a building that's not going to be occupied for some time. It's not one of these overnight things in an office, or we're really seeing this in hotels and hospitality. We see them placed all over the place in those occupied buildings. This is an area where ozone has its use in the restoration industry.
we had a question in our Q&A, Bob, about if ozone would be a good technology application for a school. And I'm not fully clear on the question, but if there's an application within the schools where maybe it's cleaning in that scenario like I just described in the office, is there a way to do that safely?
You know, again, are you exposing people? And are you exposing people to the byproducts created by ozone? So if it's a school that's going to be occupied tomorrow, or you do it on Friday, it's going to be occupied Monday, I tend to stay away from it because we just don't have that reassurance that number one, the ozone won't be lingering. And number two, if the ozone does react out, what's it forming? Now, on the other hand, if you have a school that maybe it's the beginning of the summer, no one's going to be in there for 2 months, and you can ventilate and open up the windows, there may be an application there. But again, it depends on the situation. And also, that kind of a side note too. I think some of the technologies with bipolar ionization and some of the UV, there are technologies out there that used to generate ozone, but now they've gotten some that are much better at not generating ozone. And I believe Underwriter's Laboratory actually has a test and certifies some of that equipment not to generate ozone. It's kind of a side note.
Yeah, that's correct, and that's kind of been a bit of a topic. There aren't a lot of manufacturers that do that, and so you kind of got to parse through the literature. We've got a little bit on that here towards the end of the secondary air cleaning. But volatile organic compounds, or VOCs, are one of these things that I think there's a lot of information and misinformation and questions about, because it seems like it's a very complicated topic to get into. I wanted to kind of break it down and see, are there good VOCs or bad VOCs, and what is exposure in some of the air quality monitoring that we're doing in buildings. We'll have a sensor in, and it'll spike and it'll say it's red, but it doesn't necessarily mean that the air quality is bad at that point in time. It just means something spiked. I think with a lot of exposure to contaminants, it's about the duration of exposure and the level of exposure that define whether it's harmful or not. And if you get a chance, we have a blog post on our website that Emmy Riley in our office posted just yesterday that kind of goes through an experiment she did in her own home, just to kind of look at the effects of what happens in your house with cooking and other things. But Rob, with your experience with VOCs, what are some of the common questions that you come into?
Yeah, I think there's a lot of confusions around VOCs, especially when it comes to testing. I know some of the easiest ways to test are just measuring, with the there's really good sensors out there to measure whether or not you have VOCs in your space, right? You can sit there and photoionization detectors, even smaller sensors, they've gotten really good, and they'll give you a concentration, but they won't tell you what it is. And there's a lot of difference in the toxicological properties for various VOCs. For example, there's the alcohols, isopropyl alcohols of VOC, right? It's gonna be found in a lot of your hand sanitizers. It smells, right? You're gonna smell that. It's gonna set your sensor off quickly, but it's really not that harmful. Then you have other VOCs like benzene, where it actually has a fairly pleasant, sweet odor to it. But if you look at the exposure limit, it's very low. Benzene causes leukemia. We don't want to be exposed to benzene. So your sensors don't necessarily differentiate between what VOCs are there or not. It just tells you that they're there or they're not there, right? So one of the complicating factors is if you start getting hits on a VOC sensor, you really need to look in and say, what's the source? Is it that hand sanitizer in the lobby that's causing your sensor to spike every time you?
Yeah, and I think that's how I've kind of associated my thinking of VOCs over a long period of time. Is if I can smell it, maybe it's bad. I always think of VOCs as kind of being that new car smell or fresh paint and things that you might have in your building. But the industry's done a really good job of paints and adhesives and material in the buildings and reducing to no and low and no VOC levels. So,
One thing about VOCs too, Ben, is sometimes it's not about the toxicity, right? It's people expect their building to be odor free, right? So it doesn't matter if it's a VOC that's not hazardous. People don't want to go to a place that smells, regardless of whether it's safe or not. And one of the analogies we use is odors out of context, right? If you're in a garage or a maintenance shop working on a car, you expect to smell some VOCs, right? You're not thinking, is it hazardous or not? You're okay. That odor is in its context. You take that same smell and you move it to an office building where the odor is out of context, it's still probably not hazardous, but it's not going to be acceptable either.
Yeah. And I think, one of the questions in our Q&A, and by the way, if you just joined, we have a question and answer section here in the Zoom webinar here that you can go ahead and just type your questions in and we'll make sure we answer them along the way. One of the questions was, you kind of addressed this, are all VOCs equal? But the question continues, are there some that we should be more concerned about than others, which I think you've addressed, but in natural sense, essential oils and things of that nature cause negative side effects, headaches, and things of that nature? I think the answer is yes. They do cause some of those side effects.
Yeah, well, one of the things as industrial hygienists that drives us nuts is we get safety data sheets, right? Everybody knows that safety data sheets. One of the things that's exempted from safety data sheets that they don't have to tell you what's in there is anything that creates a fragrance. So if it's an essential oil, it's a plug-in air freshener, they have proprietary rights not to tell us what chemicals are in there. Just so I don't know if that answers the question directly or not, but the short answer is often we don't know. We know they're VOCs. And other compounds like the paint, we can look at the safety data sheet and figure out what it is and if it's more hazardous or less hazardous or more odorous. But when you start getting into the intentional fragrances, whether it be essential oils or like I said, the plug-in stuff, that's where we don't even know what it is, and they don't have to tell us.
Right. I refer back to Emmy's blog post. I think the link went in the chat here if you're interested in that. Part of her experiment, I went into some of the natural fragrances from an orange peel versus a diffuser that was putting smells into the space. And, we have a couple of buildings, and we see this a lot in hospitality, where they have scent machines and things that generate a brand and proprietary smell from those, and those are VOCs being put into the air. Yeah, another point here, and you kind of touched on this. We have a few clients that have come to us with concerns about seeing those red spikes in their air with the lobby air quality sensors and the VOC spiking. And we've been able to clarify. That's when people walk in and they use the hand sanitizing station by the elevators. That's been a lot of that spike, but that's not necessarily a bad thing.
Kind of a side story too, Ben, is I did a project. It was in Colorado where there was one room in a school actually where there was concerns, and they had sensors throughout their building, and one sensor kept spiking and spiking and spiking. I flew all the way out there and found out. So they had one staff member who wore a lot of perfume, and we were able to watch the room for the day. And when she walked in, the sensor went up. When she walked out, the sensor went down. So VOCs are not always bad. They're not always coming for your building.
Yeah, it's all kind of goes back to source control when you're trying to contain viral particles, and like the viruses and things like that can kind of come into the realm of this. So I think we'll move off of VOCs if there's no other questions on that. The poll did reveal that a vast majority, over 60% of people here, VOCs make them nervous. So hopefully we kind of provide a little clarity there. Rob, this is a topic you're definitely passionate about, but this is one of the myths you posted to us. It says mold must be killed to improve indoor air quality. And again, the very high percentage, over 60% of the people attending here in the poll had said that yes, mold must be killed. What's your opinion?
Yeah, it's one of these myths that we've been hearing again for more than ever since I've been in this this business is we need to kill the mold. And I don't believe that to be true. We need to remove the mold. Mold is very difficult to kill. And if you look at the EPA guidelines, the standards out there, the professional guidelines, the approach to when you have mold in your building is to remove it, not to kill it. And this ties back to the ozone, uh, where we potentially have people using ozone generators to try and kill mold. And the reason I say this is based on on how mold affects people. Less than 5%, well less than 5% of mold health effects are from mold infections, where someone actually inhales mold and it grows in their lungs or they get some type of infection. Live mold causes infections. 95% or even greater, I would say it goes as far as saying 99% of the time is allergies or asthma, or someone's concerned about the toxic effects of mold, which are also somewhat controversial. The reality is the chemicals that cause the asthma and allergy effects and the toxic properties of mold are there whether or not the mold is alive or dead. It doesn't matter if you kill it, it will still be there and still cause those same health effects. So we need to remove it and not kill it. And an analogy I use is when we talk about mycotoxins, we all know poisonous mushrooms, right? If you take a poisonous mushroom, you dry it out and you kill it, would you still eat it? It's the same thing with inhaling mold. If you kill it, the properties that cause the problems are still there. So we generally recommend if you have mold in the building, like this picture of drywall here, we wouldn't spray it with bleach. We would just get a Sawzall and cut it out and just get rid of it, as opposed to trying to kill it. So it's one of my little pet peeves when I see these promotional pieces that say we kill the mold. Well, great. You're probably not going to be doing much to improve indoor air quality with just that step alone.
Yeah, and I think it also it's not really about killing mold, but preventing mold is really
Oh,
and when we design buildings right now, they're becoming tighter and tighter. Insulation properties are getting more and more, and the location of vapor barriers, the conditioning of air to certain conditions
right.
to prevent mold from forming is extremely important. I know that not to believe all the architecture has caught up with the way that we design insulation systems right now. And we've seen a lot of buildings where wall systems, all of a sudden insulation is falling off because it's getting water and moisture behind it as the vapor barrier was in a different position because the heat transfer across the surfaces changed, the dew point changed. So there is technologies out there that can help you keep your moisture levels right in your automation systems, but you can also use air quality monitoring to make sure that. So on kind of jumping into that, there was a question here I saw pop up: is mold airborne?
It depends on the species, but mostly yes. I was, mold releases spores and to reproduce. That's how it proliferates in the environment. So the vast majority of spores are mold species use airborne dissemination. It's kind of like a dandelion in your yard, right? It's putting out those seeds. It actually looks very similar, and it releases those seeds into the air, and those are what you inhale. And those are what contain both the allergenic properties and potentially mycotoxins attached to the spores. There are some molds, Stachybotrys is black one you see in the picture actually, that do not readily produce spores into the air. They do sticky spores. They like insects or other things traveling across it or water traveling across it to move their spores around and reproduce. But I guess the simple answer to your question is yes, mold spores are airborne and therefore an inhalation risk. But to build on your point, Ben, I think it's a good one. We talk, the thing is, do we need to kill mold or do we need to remove mold? If you don't stop the moisture source or the source of what caused the mold to get there to begin with, it's going to come right back. It always will. If it has moisture, it's going to grow. Anytime you're on a mold project, before you think about how you're going to kill it or remove it, you need to stop the moisture source. Otherwise, you're going to do the project over and over again. It's spin your tires.
Once you have it, that research into figuring out where it came from and how you got it is an important step to go through. One of the questions I think in the Q&A part was about, when you get it on concrete or underneath flooring systems, because there was a flood in a unit, do you need to cut that floor out and clean everything? Or do you just dry it out and hope it goes away? What have you seen in that kind of realm when like disaster response scenarios?
Yeah, you need to get in there and remove it quite frequently. It's not pleasant. It's a lot of work that needs to be done. Um, but I mean, just if mold is in a wall cavity or below, wooden flooring on the subfloor, it's not going to go away by itself. There isn't a magical ingredient you're going to inject there to quote unquote kill it, whether it be ozone or some other chemical. That's not going to do you any good. You got to remove it.
When you get something like if you have a flood and you have it under your floor, how do you know it's there? Like, is it because you start having symptoms? Do you notice it?
Yeah, it's sometimes it's symptoms. Very often it's odor, so you get that musty odor, right? Sometimes there's general guidelines. You'll know when it's there or not. I mean, obviously if you have a flood or something, it takes mold a good 48 to 72 hours of having decent amount of moisture content to be able to grow. So if you know there's been water trapped between two surfaces and one of those surfaces is porous, whether it be wood or drywall, and it's been wet for a week, you're going to have mold. It's pretty much goes without saying. On the other hand, if you dried it out quickly, then you know it was dry within 48, 72 hours, you're not going to have mold.
If you don't know it's there and you don't have the smell necessarily, is there a relationship to, I think this goes maybe one of the questions in the Q&A, is there a relationship between VOC levels and the amount of mold spores that might be in the air? Is there any kind of relationship to track it from the indoor air quality?
Sure, it's very difficult to determine whether the VOCs in the air are coming from mold or not, but mold releases what we call microbial volatile organic compounds, called MVOCs. So they're VOCs created by mold. And what those are typically, those are your musty odors. So when you have a musty odor, you're usually smelling a VOC generated by a mold. And what that is happening, I mean, actually what's happening is the mold is digesting whatever nutrient source it's growing on. And that could be wood, it could be drywall. And then it's just like we do when you eat something, you eventually release gases, right? That don't smell very pleasant. So that's what microbial volatile organic compounds are. They're literally mold flatulence. But it's that musty odor you get, and yes, they are VOCs. Again, your sensor might pick something up, but it won't tell you if it's an MVOC or if it's coming from the hand sanitizer. That's where VOCs get complicated, and you almost need lab analysis to differentiate and figure out where it's coming from.
Yeah, and that's been our approach in buildings when we see total VOC levels it doesn't tell us anything about what's actually in that air. It just says there's a bunch of it. And if we're seeing it for elevated levels for extended periods of time, that's when we need to go and do, like you said, the lab test to try to determine what element in the air is actually happening. That helps us kind of determine what the source might be of the problem.
Yeah. Yep.
But there was a question, I think it's probably in your wheelhouse here too, Rob, about one of the attendees had mold in their house and they were told they needed to bomb the house to get rid of the airborne mold. Is that something you have experience with?
I wouldn't have experience with it because I tell them not to do it. No, you don't bomb a house to get rid of mold in the air, because whatever mold's on surfaces is going to still release more mold into the air after you bombed it. Your mold spores that have been generated by the mold are going to be there if the mold is alive or dead. You're not removing those. If you have mold in your house or there's an organization, IICRC, the Institute for Inspection and Restoration Cleaning Contractors, I believe, but it's just IICRC. And they have guidelines for how to clean up mold in your home, and hire a contractor that follows those guidelines. And I haven't looked at those guidelines for a while, but I'm fairly confident they're not going to say bomb a home with a fog or any type of disinfectant like that. So if you do have it in your home or your commercial building, I really recommend going to IICRC's website and finding a contractor that follows their procedures, because they're reputable. It's an ANSI standard. There's a lot of people selling stuff out there you probably don't need.
It's the Indoor Air Quality Association, IAQA, and they also have really good recommendations and guidelines. And if you're working with a contractor on remediation or disaster response to floods like that, IAQA is a great organization to track for a contractor. Well, I'm sorry, I did have one more question here. I just missed on mold in buildings, and the question was related to whether we've seen mold generation due to poor moisture control during construction. I think that's an excellent question, and I can say, in my experience, we've done a lot of work with buildings that they tend to be smaller buildings that were wood, stick built. Maybe a small commercial building has a rooftop unit that cycles on and off to heat and cool, basically, but it's not really set up or configured to do the dehumidification. And in the first year of operation, once the building gets sealed, experiences in the cooling season, very, very high levels of moisture. And we did some data logging on several of these buildings. And you see when the HVAC unit stops, the moisture climbs up almost instantly. And a lot of times that's been because of retained moisture in drywall or behind the walls or other building materials. And our efforts to try to fix that have been looking at putting dehumidification controls in. Basically what that means is subcooling your space to where it's not really comfortable to be in there. Really, after you go through that first winter cycle, we've seen a lot of that moisture go away. I haven't had a lot of experience seeing a lot of mold growth from that, but I don't know, Brad, if you or Rob, if you've had any experience with that.
Yeah, we've been on a number of projects like that, and I think there's one of the main things that we've seen is concrete takes a long time to cure. A lot of buildings are built with a lot of poured concrete, and contractors get frustrated waiting for that concrete to be at the right moisture content. So they sometimes push the project along a little bit too quickly and start constructing the shell of the building and trapping all that moisture that's coming off the concrete into the building while the concrete is still curing. And that results in, as you mentioned, Ben, a lot of humidity issues. Once the building's constructed, sealed up, and you see condensation start forming, and we have seen that cause fairly extensive mold growth in buildings, traced it back to improperly cured or not completely cured concrete.
Seen that in a large warehouse application where they actually didn't put a vapor barrier underneath the floor. And what happened when they sealed it, it was in Pennsylvania, and they sealed it up, opened the building, they brought in all these boxes and put them on the shelf in this half-mile long facility. The temperatures were right at the dew point level where the outside air that was in the building couldn't circulate out. And what happened when you walk in there, the whole building was filled with fog. And every box was starting to deteriorate. Some mold was starting to form on surfaces. And one of the ways that we solved this problem in the interim was to go ahead and come up with a sequence and to try to make sure we introduce the right air at the right temperature at the right time. So essentially, we dumped a bunch of heat in the building, even though it was cooling season, just to try to dry things out and get everything to the right temperature. One of the questions is about, is there a specific temperature or relative humidity that would prevent mold from growing? I think the key from a control standpoint is keeping from hitting the dew point or nearing the dew point temperature on surfaces that would be susceptible to mold growth. And that's, cold, dark areas are great places where mold likes to live. And, if we can, like I said, I think at the beginning, the vapor barrier placement is extremely important, and understanding what the surface temperature is going to be relative to the temperature humidity levels that you're maintaining inside. There was a question that says, the musty smell is characteristic of small boutiques with unitary air conditioning. What can those non-tech users do to prevent this practically? Yeah, that's a great question. I think it goes kind of back to unitary air conditioning cycle on and off. So what can you do to kind of remove those odors and the musty smells of things? I think that what I see a lot of in restaurants, and I see it in a lot of retail, is that the air conditioning turns on when it needs to cool, it shuts off when it's fine, it turns on when it needs to heat, but otherwise it doesn't run. And I think I'm surprised to go to a gym at a hotel, or they don't have the fans running continuously. I think that's one of the things you can do, is set the fan to run so it's filtering and you're doing things. But Rob, if you have any other opinion on that.
And I apologize, I had a difficult time hearing the question. I can't see it on my screen, but it sounded to me like it was, how to get rid of the musty odors when the air conditioning is cycling on and off at various times, not on all the time. I think number one answer is probably why you have musty odors to begin with, and because obviously that's related to some microbial growth somewhere, and it could be as simple as dust building up in the coils. It could be biofilm in a condensate pan, but trying to identify why you're getting those musty odors, number one. Number two, reducing the relative humidity through having these fans run continuously. And I mean, quite honestly, if you've been off topic, but this goes back to a lot of the COVID guidelines we're seeing right now. Is one of our bigger concerns is demand controlled ventilation, where you have a system that cycles off when the thermostat's satisfied. And so you might have a building that's bringing in good ventilation most of the time, but no ventilation some of the time. So getting fans to continuously to run, and again, I'm not an engineer, I'd leave this up to you, Ben, to adjust maybe the coil temperatures or whatever might need to be done so the fans can run continuously and provide the proper dehumidification.
Yeah, I think that's a good lead in to our next topic of secondary air cleaning. I did want to address a question we had. There was more of a comment here, but we talked about measuring total VOCs, and the comment was made, there's no industry definition for what a total VOC is.
Mhm.
Sensors, they measure total VOCs differently. They use different technologies to count what
Yep.
VOC is in here. And so I think that's an outstanding point, and yeah, I appreciate that comment.
Yeah, that's true. The sensors can't differentiate between VOCs, and they assume all VOCs have the same mass. They all think it's like isobutylene, I believe. And so what you need to do is you need to say, okay, my sensor is a screening tool that tells me when I might be having problems, but it's an estimate. It's not going to, you know, tell you exactly the concentration of VOC, because it's treating all VOCs the same when they're not.
Yeah, and that's that's another one of those places where if you see total VOC levels high, you need to do deeper investigation to figure out
Right.
what.
Right. It's a great screening tool, is what it is, but it's still a screening tool.
Yep. So yeah, leading into secondary air cleaning and talking about that, in no particular order here, kind of address it. We're talking about things that can be done to take some of the smell out of air in HVAC systems. And one of the things that it's had a lot of conversation here through the COVID life that we've lived the last year or so is ultraviolet germicidal radiation and or UVC technology. So where I've seen it in good application is and it's been in this application for years, but a lot of people like to put them facing their cooling coil. And they only run it during cooling season, but it does an excellent job of keeping the coil clean and keeping the bacteria off of that. And that can be a source of a lot of odor smell, is the bacterial growth that happens on those units. I've also seen it recently in healthcare applications, commonly put on the filtration bank to deactivate any kind of viral particles that might get on there. Less successfully because it has to be very designed. Commonly, you can put it in duct. It needs a certain length of exposure, time of exposure to deactivate viral strains. And the other place that it's very common to see is in hospitals. You might see it at a nurse call station and up high in the ceiling. They'll call that upper room ultraviolet. So, Rob, do you have other applications or?
Yeah, no, I think that's right. I think we need to be careful with the safety of UVGI as well. Whenever we have UVC, we want to avoid exposure to maintenance people to the light. Like any of these technologies, you got to use them for the right thing, right? Like you mentioned, they work great on cooling coils. They may work in air ducts if you get the right velocity across it of your airstream. You got to think too, where do I want to treat the air? Because these are point source treatments. They don't provide any residual. So if I'm putting it in the air duct, is my contaminant in the air duct? Is coronavirus actually in the air duct, or is it in the airspace in the room? And with COVID, it's mostly within the airspace in a room, mostly. So your upper room, like you mentioned, where it treats the air above a certain height in the room, is probably more valuable than in duct. So it's just a matter of thinking, where do you want to, why are you installing it, then installing it properly.
Yeah, it's also installing the proper technology. You don't see it too often. Most everything's UVC, but other bands of UV can be even more dangerous to your health by emitting ozone. And some of the technologies here can generate dangerous levels of ozone. I think we talked bipolar ionization is I think an interesting topic here. There was tubular bipolar ionization that's been around for a very long time, used a lot in industrial applications, but it can produce levels of ozone that could be potentially dangerous. There's needlepoint bipolar ionization, which can actually not produce ozone, but it's all producing ions. And I think, Rob, you mentioned and seen a study that IIT had recently published, I think last week, on bipolar technology and how effective it was.
Yeah, there's a number of studies. I mean, the bipolar ionization, we could probably talk about that for 4 hours today, right? We're getting these questions, daily. There's a number of more recent studies out there. If you go back and look at the National Institute of Health studies, just even a few years ago, they say it's very safe with the negative ions, at least. There was a study that came out of China last what was it, September or October, that says, listen, if you have very high levels of ions in the room, it might cause oxidative stress to the room occupants that may be more harmful than the actual particulate it may be removing. So anytime we're introducing something in the air to control something else that potentially is problematic, it has been shown in certain situations to remove a lot of the particles through agglomeration, having the particles, adhere to each other and fall out of the air. The study that came out of IIT last week was really interesting because it showed actually a shift in the particle mass. So what they found was, yes, it's causing some particles to agglomerate, but you're taking the very, very, very small, nanometer particles, submicron, and making them to micron particles. So they don't really fall out of the air. You're just taking them, taking the particles that are floating in the air and making them bigger particles that are still floating in the air. I think it was generally what their findings were. For the most part, there's some nuance to that. And what I've seen in general is that it does have good, like everything else. It has its place. If you're in an area with a lot of wildfires, California, Colorado, and you have a high density of particulate in the air in the room, it might actually work fairly well at knocking those particles down. And the slight potential for health impacts from the negative ions, your exposure to particles might outweigh that, right? You might have more risk to those particles. So like anything else, think about where you're going to install it and why, before you do so, and do some homework on it.
Yeah, and I think it's also important, if you are installing, to understand what it's doing. A couple applications I've seen, actually most of the applications I've seen with bipolar ionization installed, we haven't seen that anybody's actually tracking the ions in the air. And so I think that's to your point, it's important to understand what things are happening. Then there was a question, I think, earlier about with bipolar ionization, can there be acceptable levels of the byproducts that are emitted? And again, I think that's kind of what you were addressing there, Rob. Is there are byproducts that are emitted that need to be careful of, but again, if there were a product that produced ozone, OSHA does define acceptable limits of ozone. There are limits to everything. I don't know if you want to comment on that any further.
Yeah, no, in bipolar ionization, it's really complicated fast when it comes to byproducts, because it's not just the ozone, it's not just the negative ions or positive ions. What it is it's also basic claims is breaking down VOCs. And you'll see this in the IIT study, and anecdotally is what we've been thinking for a while, was you're changing the VOCs. Okay, so you may have one VOC, and when you oxidize it, you're making it into something else, which is another VOC. Now, eventually, if you change it enough, it will eventually become probably just chemicals that are not hazardous, but broken down to their simplest forms. But what are the intermediate compounds in there that you're changing it into? And it gets the air chemistry here gets pretty complicated pretty fast. The IIT study actually, I think, does an excellent job explaining this and saying, here's the VOCs we started with. We used the bipolar ionization. Here's the VOCs we finished with, and they're different.
Yeah, and I think that that's interesting to go into the poll question we had about this. Was, have you been told that bipolar ionization will protect you against COVID? And about half of the audience has heard that. And I think the common misconception that I've seen is that people are trying to take a singular technology that may have been designed for specific applications and trying to apply it to everything, when in reality, safety and protection, and you're trying to reduce your risk of exposure to things. And like you said, Rob, earlier, like the virus for COVID lives in the space that you're in. And so you might have bipolar ionization that could be effective in a building. If you don't have air circulation, people have virus, and you're near them, your exposure to the bipolar system doesn't really do you any effectiveness. And then there was a question here that goes into the UVGI and UVC. Is it a good idea to use it for protection against COVID? My answer to that is it depends. It depends on what level of filtration you're putting in. It depends on how your building is set up. It depends on how many people you have, and again, the localized risk exposure. To me, I like seeing UV lights on cooling coils. I don't mind seeing them on filters, but filters can be changed. To me, we've been recommending mostly that people have MERV 13 to MERV 15 levels of filtration on their building, and that they work on and make sure that they control things. Rob talked about demand control ventilation, not under ventilating the space, But then the part that I think has not gotten enough attention has been localized ventilation rates. We look at office buildings in Chicago, and a lot of them have been designed in the past 30 years with variable air volume systems, and to prevent office spaces in the interior of the building from getting cold, super cold in the summer, they shut the VAV box will shut completely off. It's a shut off design, which goes against some ventilation codes now, but at the time that was acceptable. And what that means is you don't necessarily have any air circulation, and your risk of exposure to not even just COVID, but any viral strain or bacteria increases in that case.
Yeah. I think Ben, to build on this is just a basic point for all of this is just because it's older technology doesn't mean it doesn't work. Some of the this is back to the basics, right? Even for COVID, it's are you bringing enough outdoor air? If your ventilation rates are fine and your dilution rates are fine, that's your number one control for most of these, for VOCs, for whatever. Now, bringing in outdoor air is expensive because you got to heat it or cool it, right? So we want to filter it. Mechanical filters, HEPA, MERV 13, MERV 14 work great. So now if you don't have the ability to bring in enough outside air, you don't have the ability to provide decent mechanical filtration. Now let's start talking about what else we can do to supplement that. And that's where I think the UVGI might come in, maybe bipolar ionization, whatever. I would not make these my first line. I would use them as stopgaps. And an example might be a restaurant, right, where you got perimeter radiant heat, no ventilation, and a window air conditioning unit. So you have no ability really to filter the air or to bring in outside air. Okay, well, let's get a standalone portable HEPA filter. That's probably your best bet. You want to throw some upper room UVGI, maybe you want to supplement it then. But think about what you can do with the basic stuff that we know works first, right? And none of this we know works for COVID. COVID is it's hard to say we don't know, but with COVID, we don't know. It's been around for a year, right? So early on, we were doing this whole cleaning stuff. We were cleaning and sanitizing everything because we thought, and that's what we believed, that a lot of the stuff, disease transmission was coming from surfaces. Well, we didn't know. We were guessing. And now we know a lot of it's coming from air. Okay, we learned that. And a lot of it goes with the bipolar ionization, the UVI, the PCOs. Will it work against ozone or against coronavirus? We don't know. And if someone's telling you otherwise that it will, they're guessing. And it's just because it's a new virus, right? We don't know what we don't know. But we do know traditional technology for any type of particulate. Dilution air and mechanical filtration works, and virus is a particulate. So, sticking with your good filtration, your outdoor air is your number one.
And I would add to that, this goes back to, I think there's a comment, I've seen this a couple of times on our questions, like, should we use bipolar ionization or not? Should I use UVGI or not? Like you said, it's a secondary line of defense. It's application specific, whether it's going to work in your space or not. And so that's where you want to have an expert come in and look at it. I don't ever think you should take a vendor's word for it's going to work. I've seen very expensive UV systems put in a return plenum of an air handling unit, which is going to do absolutely nothing for you. So, it's about understanding where it's going to go, what it's going to do for you. It's very specific to your building and the use of it. But again, the dilution of air, the ventilation, the localized air quality is going to be the most important place to focus your time, money, and energy. There was a question here I thought was kind of interesting, and I've seen it a little bit, Rob, but maybe you've seen or heard a little bit more about it, but using hydrogen peroxide, to disinfect surfaces or the air.
Yeah, no, vaporous hydrogen peroxide has been used quite a bit in the healthcare world. That's something that we use. If we have a room, someone that has an infectious disease in a hospital or healthcare, going in there afterward with vaporous hydrogen peroxide to help clear that room out before you get the next patient to reduce the risk of nosocomial or hospital-acquired infection is dry hydrogen peroxide, not VHP. I'm not too familiar with dry hydrogen peroxide as opposed to vaporous. What I would say is that anytime we're introducing something into a space that someone might be breathing, just be careful. Whether it be dry, I'm assuming this is the dry hydrogen peroxide would I'm assuming it'd be something you generate airborne through either fumigation or something else. Don't know what dry hydrogen peroxide means. But yeah, anytime you're introducing something into the airspace, someone might be breathing, be careful. And keep in mind also that hydrogen peroxide is there. It doesn't activate viruses. It does work really well against bacteria. But then again, it might also change some things into other things, right? And be irritating to the building occupants. So just be careful when exposing people to this stuff.
I want to spend a second on filtration too, and understanding that since we're on that topic, we are going into well building standards, and the carbon filters are part of some of the requirements within that program, or ability to have that kind of application potentially. And we get asked a lot, well, what does that do? What does carbon do versus a regular filter or a HEPA filter? Do I need HEPA filters on everything? And our answer is it depends on what's in your air. So, in a building that's going to be near a lot of fumes and gases, carbon is one of those technologies that absorbs the gaseous contaminants within the air. You go to the airport, you don't smell jet fuel when you're walking around the terminal because there's carbon filtration cleansing those contaminants out of the air. In the city, a lot of times we have restaurants, and people don't want to have the odors going into the residence units and the condos or apartments above that. And we use air scrubbers, which are just carbon filters. We've run into quite a few odor complaints in buildings where they smell the steak, they smell seafood, they smell things that are not great in their home, and it's generally because the carbon has depleted in the filtration system. And it's different than a normal filter, like a MERV 13 was kind of the most common filter in our poll that we had people had in their space, and that's great. That's the kind of the minimum bar right now, and those filters are great at taking particles out of the air and capturing contaminants of certain sizes. Doesn't mean little tiny particles can't get caught. They can on any filter, but the those can get changed out based on how loaded they get or based on time frequency. With carbon, it's depleted based on what it's absorbing. And one of our engineers in our office, Frank Cohout, is an expert on this in the ASHRAE, and they're trying to determine, is there a way to level look at different products, cooking and what kind of contaminants come off of it. It's a very complicated equation. So there was another comment here about are air purifiers effective? Are different types of air purifiers more appropriate than different applications? Ergo, carbon versus HEPA. So I was trying to address that with the carbon versus HEPA. But when it comes to what are you seeing, Rob, when it comes to portable air cleaners and HEPA control?
Well, I think obviously when you're talking about carbon filters versus HEPA filters, you're talking about two different things, right? Your HEPA's taking out your particulate, your carbon's taking out your VOCs. Between those two, back to back, you're getting a vast majority of the potential air contaminants. You're not getting all of them. I mean, there's some aldehydes that won't bond to carbon. There's other chemical compounds that carbon will not take out. And obviously HEPA does not take out gases. So there's some that are going to get through. But if I were to sit there and say in my own home, if I were to put something in there, a HEPA with carbon is going to take your particulate, it's going to take your VOCs, and that's going to get us most of the way there. Maybe not all the way, like if you have mold growth or something along those lines. But these are established technologies. We know how they work, and we know that they do work. In your buildings, you might have problems, and again, this is more of an engineering person. You might have problems drawing enough air through a HEPA filter with the pressure drop. Right, you might have problems, as you alluded to, Ben. Your carbon beds overload, and they become loaded up, and then they're no longer effective. Mm-hmm. There are some other specialized filters out there, potassium permanganate for various things, but for most of the stuff, you put your carbon with your HEPA, you're going to capture a lot of stuff and do a good job.
Yeah, so kind of wrap up on filtration and kind of where it goes. We do see the portable air filters a lot, and schools are putting them in classrooms. You got to be careful about the noise level of them because they can be loud. When it comes to HVAC systems, we don't recommend HEPA filters for most commercial office buildings because of the amount of energy it takes to push air through them. And while they're extremely effective at getting very small particles, I kind of should put this up earlier, but here's a slide just kind of explaining how micron sizing kind of relates to things that we might relate to. they can take pretty small particles out of the air. PM 2.5 and PM 10 are two of the particulate pollutants that have industry standards related to them. The EPA and the NIOSH standards kind of regulate what is considered acceptable levels of particle size for exposure limits in these ranges. But when we're looking at buildings, some of the analysis is we're going to MERV 13, we're going to MERV 15. They are making filters now in certain sizes and certain applications that don't have to necessarily increase the pressure drop, and we don't have to get a bigger motor, spend more energy. So, I think the response right now in the industry that at least that we're taking on is, let's go out and see what you have right now. What are you doing? Let's put in the best practices and see how effective those practices are at removing things from the air. We might spend a little bit more energy bringing in a little bit more ventilation or pushing air through a better MERV filter, but in the long run, we'll be able to hone that back in using data. And so that's probably one of the last places here. We're right at our time limit, so I'll kind of close up with what we're doing at Cyclone and what we're working with Ramble here. We are wanting to measure what's going on in buildings, and if you go and put these technologies in, if you go and concerned about VOCs, and now we're also concerned about what's running around in the air, but if you don't really know what you had before and you don't really know what you have after, you don't know how effective things are. So we're really excited today to announce that Cyclone has released a program we've been developing for almost 3 years called Airplan. And I think some of the folks on this call are early participants in this program, but essentially we're providing a monitoring of the air quality within the building. We're helping to evaluate those things when we see that there's an issue, say with total VOCs, and we want to try to dig into it, and we want to make sure we understand where the source of the issue is. We've got experts like Rob here that can come into the building and help identify things and give you more confidence. So this is more than just a building reopening program. This is really meant to be something where we do, like we talked about, where we go in and make these changes, we get the building healthy, people can move back in. We'll have to make more adjustments as the buildings become more and more occupied because we'll see the data changing. But in the long term, we're going to want to dial things in and balance it back with energy efficiency again. So we're really excited to announce this program. We have a great sensor platform that we use. So if you're interested in learning more about this, reach out to us. We'll be putting some more information on our website and reaching out to a lot of you individually. But I wanted to spend the rest of the time here with any questions people have. And I see one more question here. What are more effective methodologies for dealing with ventilation and COVID? Do we need targeted ventilation?
Yeah, I think the most effective thing, COVID by far is still transmitted almost entirely within the airspace of one room. You still, I don't know of any cases where it's gone into a large centralized air handling unit and in one return and then getting spit out the supply. It's a difficult journey for a virus to survive. So treating the air in the room with dilution ventilation. If I had one thing to say, is just making sure you're getting enough air into the room and diluting anything that might accumulate within that airspace. I think that takes priority over filtration. It takes priority over everything else. Open windows. Don't allow stuff to accumulate within an airspace. That's I think the number one thing.
Yeah, and I agree with that. And I go back to with COVID and being protected in the space. The kind of the funniest thing I think I've seen all year, and I don't know how funny or sad it is, but when they banned indoor dining but allowed outdoor dining, and it was minus 10 degrees out, everybody just put up tents that had completely sealed up with no ventilation whatsoever, and it seemed bizarre that the mentality there is not understanding that we need to circulate air, we need to clean air, we need to remove contaminants from it. And so does anybody have any other questions for us while we're here? We appreciate you joining us on Earth Day, and hope this has been beneficial. If not, I don't see any additional questions here. If you do have other questions, we've got our contact information on this slide. We'll be posting a recording of this to our website in the next day, and we'll send the link out to that. And we really appreciate everybody's time. Rob, thank you so much for joining us. I appreciate all your insight.
Well, thanks again for the opportunity. It's always good to work with you.
Absolutely. You too. Well, great. Thanks, everybody. Have a great Earth Day, and we'll see you soon.